Hello students, welcome back to RD Chemistry. Here I'll discuss Dalton's law of partial pressure. Suppose we have a cylinder in which there are say three gases, gas 1, gas 2 and gas 3, and these gases do not react. Remember, gases do not react. Then we can find out the total pressure. If I find out the total pressure using pressure gauge, it is found that it is the sum of partial pressure of the individual gases. The small letter P1, P2, P3 stand for partial pressure. Okay. Now how to calculate partial pressure? So partial pressure is equal to mole fraction into the total pressure. Suppose I want to calculate the partial pressure of the first gas is equal to mole fraction. What is mole fraction? Mole fraction is equal to number of moles of that gas 1 divided by total number of moles N1 plus N2 plus N3. There are three gases into the total pressure Pt. Suppose I want to calculate partial pressure of the second gas is equal to number of moles second gas divided by total number of moles N1, N2 plus N3 and goes on. So in general write Pi, okay, I component is equal to number of moles that I gas I component divided by total number of moles Nt. Okay. How do you calculate number of moles? Number of moles are equal to given mass of that gas divided by the molar mass. Now the question arises, if there is a mixture of gases are there which do not react, then what will be their average molar mass or molar mass of the mixture? How to find out? Suppose there are three gases, gas 1, gas 2 and say gas 3. Three gases are there. And number of moles are like N1, N2 and N3 are there. And their molar mass, individual molar mass of the gases M1, M2 and M3. Now to calculate the molar mass of the mixture of these three gases, then what I do is, it is equal to total mass of mixture, total mass of the entire mixture divided by total moles, total number of moles. Okay, so how to calculate that one? So molar mass of the mixture is equal to, remember, number of moles are equal to given mass divided by the molar mass. So molar mass into number of moles will give the mass of that gas, correct? So if there are three gases, number of moles N1 into molar mass M1. So for the mixture, it is N2 into M2 plus N2 into M3 divided by total number of moles N1 plus N2 plus N3, right? This is the helpful formula. Read this question. Mixture of gases at 760 torr. That means this is the total pressure of the mixture. 55% nitrogen, 25% oxygen, 20% carbon dioxide by mole. Means these are number of moles itself by mole. What is the partial pressure of the each gas in torr? So I want to calculate partial pressure of the first one, nitrogen gas, is equal to number of moles of the nitrogen divided by total number of moles into the total pressure. This will be the mole fraction actually. This is the mole fraction, which is equal to, now we need not convert these percentages into the number of moles because the percentages are by mole they are given. Okay, so 25 divided by total, we go 55 plus 25 plus 20 is 100, total moles 100 into total pressure 760, and this will be equal to 418 torr. Okay, similarly partial pressure of the oxygen gas is equal to 25 divided by total 100 into the 760 total pressure, and this will be equal to 190 torr it comes. Similarly, partial pressure of the carbon dioxide is equal to remaining 20 divided by 100 into 760, and this comes to be equal to 152 torr. These are the partial pressure. When you add the partial pressure, I should get back the total pressure 760 torr. Okay, fine. Next question, calculate mean molar mass of the mixture of gas having 7 grams of nitrogen, 22 grams of carbon dioxide and 5.6 liters of carbon monoxide at STP. Previous given formula, molar mass of mixture is equal to, if there are three gases N1, M1, N2, M2 and N3, M3. Number of moles multiplied by molar mass divided by total number of moles N1 plus N2 plus N3. Okay, so we'll calculate individually. I want to calculate number of moles of the nitrogen is equal to, how to calculate number of moles, given mass 7 divided by the molar mass, correct, 28. Nitrogen atomic number is 14, so 28, correct. So this is equal to 1 by 4 comes, let it be. Number of moles of the carbon dioxide is equal to given mass 22 divided by molar mass of carbon dioxide. What the molar mass of carbon dioxide? It is a 44 gram per mole, right? Divided by 44. So this will be like 1 by 2. Similarly, number of moles of the carbon monoxide. How to calculate? Number of mass is not given into liters. So we have formula to calculate number of moles in terms of liter. Given volume in terms of liter 5.6 divided by the standard value molar volume 22.4, and this number given volume divided by 22.4 liters. Okay, both are in terms of liters now. So this will be equal to 1 by 4, right? So we'll go for the calculation now. So molar mass of the mixture is equal to number of moles 1 by 4 into molar mass will be 28 for nitrogen plus number of moles of carbon dioxide 1 by 2 into molar mass 22. Molar mass is 44, right? Plus 1 by 4 number of moles into carbon monoxide. Carbon is 12, oxygen is 16, so it is equal to 28. So it is a 28 divided by total number of moles 1 by 4 plus 1 by 2 plus 1 by 4, right? Okay, so this is equal to 7 plus 22 plus 7 again, whole divided by 1 by 4 plus half plus 1 by 4, half plus half, so 1 divided by 1. So this will be equal to 22 plus 14, so this gives us 36, right? So the molar mass of the mixture of gas is equal to now 36 grams per mole. Hope this is clear to you. Please do like, share and subscribe RD Chemistry. Thank you for watching.